Hello, Jose.
Hey guys.
Hey, Jose.
Hello, Mike.
Hey, Caio.
So today, iOS Dev Mentoring number 5, Solid Principles. So Jose, tell us a little bit about yourself and your experience with iOS.
I graduated as a computer engineer in 2012 from Cal Poly Pomona here in California. So we did very little low-level programming, didn't do much object-oriented programming. But my first job, we received a challenge where they wanted us to build an iOS application, and no one knew iOS development then. So I took charge on that and bought a couple of books and went from there. Downloaded some sample projects on GitHub, and try to apply those whatever I learned on those samples into my own applications. So that's the beginning of my journey as far as iOS development. But I never really picked up ways to structure my code. So I remember my first project, man, a lot of code was on the app delegate. Mm-hmm. So you can imagine how dirty the code was. And I remember I was just starting off, but every time we had to make some changes, even smaller changes, I had to do a lot of big changes on my end. It took me some time to look at the code, understand the code, and then apply what I needed to do to make the proper changes. So that went by. It's a startup, so you're expected to work fast. So I never had the time to actually take the time to improve on my code, make it better. Now I'm a little older, a little wiser, so I always take the time to improve my code, but I always find myself struggling as far as, applying certain principles. I always ask myself whether it's the same day or a couple of days later, if I'm doing it right. And a lot of times I feel like I'm a bit lost. If you will look at our code, it's a little bit better from what I've learned from reading different books, but it still I'm still a long way to go. I am improving, but I always find myself like when I look at previous code, like what was I doing here? It's not even following them, and perhaps at that point I didn't understand the solid principles completely.
Let's have a quick review then about the solid principles. So these 5 principles: the single responsibility principle, the open-close principle, the least cost substitution principle, interface segregation principle, and dependency inversion principle. So let's have a quick review. The single responsibility principle. What does it say? A class or component should have only one responsibility. And someone says, well, I'm not using a class, I'm using a struct. Thus, this doesn't apply. Mm-hmm. Well, it does. The single responsibility principle applies to functions, structs, any component. So a class should have only one responsibility. Why?
Well, if it's only one responsibility, it's easier to manage, right?
Much easier to develop, maintain, test, extend, reuse.
Yeah. And so this is actually one of the principles that I had the hardest time applying, because I just spent so much time thinking, is it doing too much or too little? I started off with writing a manager class, and I don't know how to separate it. I don't know what's considered a responsibility.
So you said you don't know if it's doing too much or too little.
Correct.
If you have to choose between doing too much or too little, which one would you choose?
Too little.
Because it's easier to manage, it's easier to test, it's easier to maintain, it's easier to reuse, right?
Yes. And that's what I tried to stick with. And then I have the issue of, I think every developer has the naming, right? What is it doing if you're going to have it separate? So that's where, I don't know what the controller that controls the controller. What do you, it leads to confusion at times. So that's when I keep it together. I'm like, okay, if I keep it together, it's more of a manager again.
Right.
Where if I separate it, what do I name this one in that class?
So if you don't know how to name something, you prefer not to separate it and not give it a name.
Correct.
That's why I like to recommend a lot of books about patterns, because by reading about patterns, you gain a vocabulary that you can use for naming your types, for naming your components. Like, what is a service? What is a manager? What is a controller? What is a model? What is a view? I prefer to have a bad name than to have a massive class that does too much. Because a name is very easy to refactor.
Right.
It's an easy refactor, right? Xcode can do that for you.
Mm-hmm.
But a massive class that does too much, it's very difficult to change because it introduces risk. A change there can break many things, not just one.
Yes.
I recommend making smaller things because it's going to give you better results.
Correct. Yes.
Next one. Open close principle. You should be able to modify a behavior without changing existing code. So modify a behavior could be to add a behavior without changing existing code. This is one of the most important principles.
Right.
Because if you can add behavior without changing existing code, you have no risk introducing changes in your system.
Right.
Your system is going to be extendable if you conform to all the other principles.
So let me ask you this, guys. As far as the open-close principle, is it such a thing as having too many? With iOS development, we use protocols, right? Is it too much to be having too many protocols? And if you're so one of the things, and perhaps I don't explain myself very well at work, but one of the developers is always telling me you can't have everything open-close apply the open-close principle to everything. Otherwise, how do you know we're going to modify this behavior? It's unlikely that we're going to modify it.
Yeah, a system can never be 100% open closed. So you need to understand the backlog in your project so you can be more assertive about which parts of your system should be more open for extension.
Right.
And those things might change. Your customers will always find a way to break your assumptions. Always.
Yes.
You want to minimize the amount of times this happens. So you need to understand, the domain and the backlog, how the system is going to evolve over time. So it's more likely that some areas of your code base will change more than others depending on the backlog.
Right.
But even though you try to apply this principle, it can never be 100%. Your customers will always find a way to break your assumptions. And that's fine. But you want to minimize those. Because you minimize the amount of work. You deliver more value doing less work. And that's what you want in your career. You want to be able to deliver more value by doing less work.
Right.
That's how you can maximize your returns, your contributions.
For me, the most important thing you need to think, Jose, is the cost of change, right?
Mm-hmm.
So I totally agree with what Caio says, that you need to take it as a fact that your customers are going to invalidate your assumptions. So you're going to have to do things, or the business is going to have to do things that they were not anticipated. So the question is, how do you adapt there? And can you adapt? That's the first question. And if you can, what is the cost of adaptation?
Rewriting the application.
Yeah.
That's very expensive, right?
Yeah, maybe that's it, right? But what you want is get yourself as far away as possible from rewriting the application. Let's say this is the worst case scenario. So all these guidelines, like the solid principles, for example, each one of them, they give you advice on how you can lower that cost of change and be more adaptable. What matters is how can we keep the cost of adaptation and the cost of the immediate next change very, very low, because ultimately this is what's going to let you ship all the time, right? And what is going to allow you to do what Caio said, which is how can you make the most with the least involvement, basically, right? So that's how you scale as well. And it's true for software, for your career, for everything.
Yeah, good points. Yeah, I like that we're covering kind of like an introduction to this or a review in this. I would love to see how we apply it, the thought process.
Yeah, it's important to put this in context. The economics of making decisions as a software developer to maximize the returns you get from this, to maximize the returns the business get, the customers get, and then the team grows and everyone grows. It's about making good decisions that scale.
Because otherwise, applying them won't make sense. Because you're gonna be faced with a dilemma where you're gonna be thinking, should I apply it or not? And if you don't understand the underlying value of those mechanics, not applying them perhaps might be easier. So you don't want to end up with the easier choice. You want to end up with a choice that is going to bring you freedom, is going to bring you higher rewards for lower risk.
Yes, definitely.
Just to clarify here, open closed is open for extension and closed for modification. So you should be able to extend your system without modifying it. That's it. And you mentioned as well protocols. Protocols is a way of doing this.
Correct.
But you just need a polymorphic interface, whatever that is. It could be a closure.
Right.
It could be a class that can be inherited. Any kind of polymorphism that allows you to extend your code without making changes to it. That's what you need.
Right.
Next, the Liskov substitution principle. Objects should be replaceable with instances of their subtypes. What does that mean?
So for me, it's like if one of your implementations does not implement anything or it causes a fatal error, a crash.
Right. So without breaking the system.
There you go.
You should be able to replace an instance with another instance of the same type or subtype without breaking the system. Like a simple example, let's say you have a protocol service and you have a function load and you pass a service. If you check here, guard let my service equals service as, I don't know, my service, which is a specific type. And if it's not, as you said, you do like a fatal error, which crashes the app, right?
Right.
So this interface is saying, I accept any service, but internally it says, no, I only accept a my service subtype, for example.
Correct.
And this is problematic because you have problems at runtime.
Correct. One of the issues that I have is that I accept the service, and maybe I only have two classes that implement. Maybe my service A and my service B classes, so I have them both there. So I'm okay. It's fine because I cover both scenarios. But as soon as you have a third one, that's when things start going wrong, and then a fourth one, and then you keep modifying.
Yeah. Another problem is if you have like two methods here, like start and stop, for example. And your my service implementation can only start, but it cannot stop. So the stop implementation, let's say you do a fatal error, cannot stop. That's also a problem in runtime because even if this function accepts it, if it calls stop, you're going to have a runtime error if you pass a my service instance. So you're not actually a subtype of service because every service should be able to handle the message stop and the message start.
Yes.
So any type that does not handle something that is exposed in the interface is a violation of the Liskov substitution principle.
And you should pick that up when you're going to implement a function. Then you need to be aware and say, okay, why am I putting fatal error somewhere? And you need to say, well, this is it. This is a signal. I must stop here, right? Or whatever you commit, and then you break it into another protocol, perhaps.
Right.
And that's why we recommend you to follow those principles. Because if you follow the principles, they already tell you to separate things into protocols. So this will never ever happen. The problem is that sometimes you have a protocol with two methods, and then you have a new implementation that only implements one, and you're like, oh, but now I need to break this into two protocols, and you look at your time, and it's like, I have only 2 hours to finish this task.
Right.
And it's like, oh, I don't have time to do it, so I'm not going to do it. And the tech debt keeps piling up. That's why, since the beginning, it's better to follow the principles, and you will never have this problem in the first place, because everything's already separated.
Right, yeah.
And let me undo this now. Because a common thing I see in code bases is something like load, and you pass here a URL string and something like this. URL. So this function is saying, I accept any string. But internally, you're saying, but this string must be a valid URL. It must be able to be parsed into a URL.
Right.
It's very similar to the protocol case, right? It's the same shape. You are converting it to another type because you can always parse a URL to a string, but you can sometimes parse a string into a URL.
Right. It'd be best to put that piece of code on the client, whoever is calling this method then, right?
Yes. Now you have compile time checks.
And this is also a single responsibility confirmation here, where you say, like, let someone else do it. The load function needs to load stuff, right?
Right.
And this is a violation of the single responsibility principle because it does two things. It parses and then does something with the URL. At least.
Yeah, this would be one of the things that it's not, I would consider as one responsibility. It's my responsibility to, before I load, to check that the URL is a proper, to see if it converts into a proper URL.
But that's two. Parsing and doing something with the URL.
Got
But
it.
if you move it here, now you do only one thing. You only use the URL.
Right. Yeah.
And you move the responsibility somewhere else.
Got it.
And you get compile time guarantees. So you should be able to replace objects with instances of the subtypes without breaking the system.
Right. This one was, it's probably number 2 on my list. And here comes number 3.
Interface segregation principle. So clients should not depend on methods they do not use. So remember we had the protocol service with 2 functions, start and stop.
Right.
And you said, how can I decide if I'm going to have only one method or 2?
Yeah.
Here's the guideline. If a client only calls start, it should depend on a protocol that only exposes start.
Right.
So perhaps you need to rethink the service protocol. Perhaps it can be broken down into 2.
One of the issues that I had is that, let's say I'm building this system that has start and stop. It usually comes that I need start and stop for that specific scenario. So I put both because my clients need them, right? And it might, this one's a really easy scenario, but you might have 3. Next thing, you're working on another similar feature and you only need 1. And then the other ones are never called again.
Maybe just create something new, just for the needs of the other feature you're working on, of the new feature. You don't need to immediately reuse the previous protocol. Just create a new protocol. And over time, if there is more and more duplication, then you abstract that even more. So if you have this guideline at heart, I think you're going to see that the cost for creating a new protocol is very, very small. Instead of just going and reusing whatever you've had, just because it happens that it has a method that suits your needs at a given point in time,
A new protocol will be 3 lines of code.
Right.
Or it could be just a function. It could be a type alias. A protocol with one method can always be replaced with a closure, and a closure can always be replaced with a protocol with one method.
Right.
It's an abstraction. That's it. Next, dependency inversion principle. High-level modules should not depend on low-level details or low-level modules. They should both depend on abstractions. What does that mean?
There should be some type of interface that you're conforming to, right? Not depending on any implementation of concrete classes. One of the examples that I always find myself arguing, and maybe not anymore as much, but as when you're adding implementation to your UI table view cell, right? You're decorating it, trying to get all the UI set up. You could find so many blogs and Stack Overflow discussions as far as do you want to add pass an interface to that UI table view cell to set the text, the colors, and all that stuff, or do you want to pass a view model or a concrete type in there? My question is, should that table view cell depend on a lower level module?
Do you think the model is lower level than the UI? I would say it's the opposite.
Yep.
You're right. Yeah, makes sense.
Application is normally like business rules, and then you have presentation and UI together in the same layer, let's say. So here you have models, services, etc. And then you have the presentation. Here you have view models, presenters, and UI views, and maybe view controllers in UIKit. So here framework specific
Yes.
stuff. Because UI is very specific. You're either using SwiftUI or UIKit or AppKit, something very specific, very concrete.
Right.
And you have your rules, your models that should be framework agnostic. You should be able to use the same model with SwiftUI, with UIKit, with AppKit,
right.
macOS, watchOS applications, it doesn't matter.
Right.
Now you can go as far as say, I also want to use my view models cross-platform. Does it create a new layer here? Now the presentation layer depends on the business rules, And the UI layer depends on the presentation layer. So high level at the top, low level at the bottom.
Right.
You don't want the UI depending then directly on the business rules. You want to know only about the layer above. So the UI knows about the presentation knows about the business rules.
Got it.
Now, the business rules doesn't know about anything below it. The presentation doesn't know about anything below it. And this is a way you can structure the layers in your application.
Yes. You know, one of the things that has helped me do this, and I could see how you're designing it, but a lot of times I've seen some of your drawings that you guys create to do module separation. That definitely helps me understand more which one are the high level modules and lower level modules. Because you're right. When I was explaining to you the UI table view cell, it is depending on a higher level, the table view cell.
Yeah.
So good idea to draw out. Another thing that has helped me determine this is to use dependency inversion is when you do TDD, right?
Yeah, TDD helps you create good abstractions because you want to solve the immediate problem to make a test pass, and you want to do the easiest thing you can do. So thus you create an abstraction in between that so you can mock it out during tests. And then you figure out how you're going to implement it in another test, in another layer, at another time.
Right.
Your system under test doesn't care how the collaborator is going to be implemented. And that's also another, you can say that's an application of the single responsibility principle, at least mindset wise, because you have your system under test and you have a specific set of requirements that you need to test. You need to check, right? Now, who cares what the implementation is going to be? What you need to focus right now is just checking those requirements from the list by providing an abstraction for your collaborator, because you don't know what's going to happen. What you do know is the requirements right now.
Right.
Going back to the UI, you said, should a view depend on a view model or on a model? It depends. If you want to create a reusable view that is independent of business rule and presentation, then you should not depend on it. For example, UI label is a view. Does it depend on your presentation layer? No. Does it depend on your business rules? No. It can be used by anyone in any context, right? It doesn't depend on models.
Right.
So if you want to create a reusable UI framework, for example, let's say you are working in an agency and you build reusable UI components so you can use in different applications with different business rules. Then you don't want to couple your UI with the presentation or business rules, like UI kit is. With UI labels, UI table views, it accepts different use cases with good abstractions.
Right.
So it depends.
Right.
All right. Back to the solid principles. You said you have most trouble with the single responsibility principle, SRP, and the interface segregation principle. Because by breaking down things, it's hard to name them.
Right.
And how to decide when to break an interface or not.
But yeah, those are the two, right?
Those two principles are about making small things. And small things are good because small things are composable, testable, easy to maintain, extend, reuse, replace, etc. All the things you want. So as a good guideline, make smaller things. I think Sandy Metz said that. Just make smaller things. It's one of the best guidelines in programming. Because imagine that you have a scale of small to large. Small things, as we said, are composable, reusable, testable, maintainable, extendable, etc. Large things, they're what? They're rigid. It's hard to move something that is large. It's hard to move something that depends on too many things, because then you have to move everything along with it.
Fragile.
So it's immobile, fragile, hard to reuse, hard to extend, hard to compose.
To test.
Hard to test. Yeah, exactly.
Hard to test, etc. So the single responsibility principle and the ISP is about bringing your components close to this side of the scale. But you as an engineer are going to have to decide where you want your components to be. Ideally, as close as possible to small, because you're going to create more composable, testable, extendable, maintainable, reusable, replaceable things.
Right.
So, components, they're larger. Thus, the larger they are, the more rigid they will be. That's why you want to follow the single responsibility principle. Because you want to end up with composable, testable, maintainable, extendable, reusable, replaceable types. And making or adding methods to a protocol makes it larger or smaller. Larger. So adding more things to a protocol will expose more methods to clients, will force implementations to do more things, and etc. So it makes things larger.
Mm-hmm.
Violating the single responsibility principle and the interface segregation principle will make things larger. And larger things are rigid, immobile, fragile, hard to reuse, extend, compose, and test.
Right.
And that's why we follow that. Even if we don't have good names for things yet. Because renaming is easy, but breaking a large object may not be that easy. It might be risky. Especially if you don't have tests. And big things tend not to have tests. Why? Because large things are hard to test.
Yeah, that's one of the things. Definitely really hard. I have not even hard to test. It's just they're not unable to test.
It's impossible.
Yeah.
Yeah, it's impossible. Exactly. That's why.
That's it. It's about the economics here. Smaller things are easy to manage, are easier to maintain, to develop, replace, reuse, and etc. Does that make sense so far?
Yeah.
Well, let's have a look at some code. So we got a big project here.
Yes, legacy code.
Yeah, but the number of warnings probably. I think we need to update some pods here. And Swift 5 conversion. Yeah, so let's say legacy code.
Yes.
Legacy code, because it doesn't have tests as well. Code without tests is like every change you make, you're not sure if you broke something else.
Yeah.
And I found a perfect class here to show the violation of the single responsibility principle. So add or update result view controller. Remember this class?
Yes. Not the implementation of it.
Yeah, it's quite old. 3 years old?
Yeah.
So, starting by the name, add or and implies something does more than one thing, right?
Yes.
It's in the name. This or that. This and that. So that's the first sign of violation of the single responsibility principle. Another sign I would look for is the size of the file.
Yeah.
300. 300 in the industry is considered a small view controller.
Really?
Yeah.
Which I think might be one of the smaller classes too.
Right. Like 300, let's say it's still manageable. It's beyond a threshold. I would say it's healthy, but it's still manageable. Above 500, I would say, okay, that you're losing control.
What happens if extensions, you still add on to the number of lines, right? So we have a class, I create an extension of this add or update results view controller, an extension, put it onto another file, add another 100 lines. You add on to this 300 plus 100, right? It's not like if you have two different.
Yeah, it's a smell that maybe there should be a separate type as well.
Yeah.
Okay.
But it depends. Extensions are very handy, especially like in the composition route when you want to start composing things that don't have a matching interface. You can create simple adapters with extensions. That should be fine. In the same module, yes, I would add up the lines.
Yeah, this is not a good excuse if someone says, okay, I'm going to have 500 lines of code broken down to 5 extensions, and they're going to live in different files.
That's why I don't like metrics, because you can gain metrics.
Yeah, or wrong metrics in this case.
The size of the file. Oh, if that's the metric you want to improve, easy. Just create a bunch of files and separate things in extensions. Right? Like, oh, you want coverage? Just write a bunch of tests that don't have any assertion.
Right.
And you get all the coverage you want. Because it's easy to gain if you set the wrong metrics. So, I would say a healthy file, a view controller, or any class should be around 100, 150 maximum lines of code. And that might seem super small. But if you apply the solid principles, you end up with very composable types. They are small.
Right.
What else? So the view controller has some views. It has a date formatter. It's a spell that probably is doing some formatting logic. That should probably be in the presentation layer, not in the controller. Some kind of
view model.
Or a presenter, something like that. It creates its own service. So this is a violation of the dependency inversion. It's depending on a concrete service.
Yeah.
And it's also a violation of the open close principle.
Yeah.
Because I cannot inject a different service here without breaking this class.
So if you go to the implementation of that class, I'm pretty sure it conforms to a protocol.
Yeah.
But that's one of the things I learned, like, where do you create an object of that class, right? And that's where I'm creating my objects on that class, which is, now I know it's not a good thing to do.
So you have an interface.
Yes.
But your controller depends on the concrete type.
Yeah. So what I would do is I would always go, if I wanted to do some mock data, I would use my mock implementation of this.
Right.
Instead of passing it as an argument. Yeah.
So I just see here a violation of the Liskov substitution principle, probably. You have two methods here.
Yeah.
And you have another protocol, a base protocol.
Right.
With a function cancel. So let's say, as a client, I invoke both methods and I call cancel. Which one will be canceled?
Yeah.
There's also the dependency inversion principle. This is a service layer component, right?
Right.
But there's a view model response type.
So your service, which should be a service abstraction, which should be part of maybe the business rules or the data layer, is referencing one layer below the presentation or the user interface.
Yes.
There's a dependency inversion violation. It should be the other way around.
Yeah.
The service layer is higher level than the view model.
Right.
Yeah, it depends how you structure your layers, but normally you want the service and the business logic to be not dependent on a specific user interface or presentation module.
Yes.
So here, a violation of the interface segregation led to undefined behavior. Like this interface allows us to call two methods, but we have only one cancel method.
Yes.
And it's undefined behavior. Which one's going to be canceled? Maybe both. Or maybe the last one. Or maybe the first one. Or maybe when I call create and then I call update, the update cancels the creation. It's just hard to understand what happens with this interface.
Yes. I think this was led from the UI. The same UI was going to create, the same UI was going to update. So, I would then continue creating this service interface because it will allow me to call either one, right? And you would only make one of those calls, not both. So that was the idea. But what this contract is saying, that you could call both at any time, right?
Yeah.
Mm-hmm.
Because it solves the problem right now, but is it extendable? It's not very extendable.
No.
So you could break this down into two protocols: add, result, or create, and another one, update. Now you can have two different implementations, and the cancel will be specifically to one request.
Right.
Or you can return a type that is cancelable, right? You can create a
task.
Task, yeah. Because another problem with an interface like this that has a execute and a cancel is that you are forcing implementations to be stateful, because you imply that you will hold state internally so you can cancel it if I request it later on. It must be stateful. You must hold the state of the current request so it can be canceled later.
Why you shouldn't, or you don't want to have a state? Is it because of another responsibility, or?
So services are normally stateless components because a service can be reused. You can pass the same service to multiple objects.
Yeah.
But if you have a stateful object shared across different objects, you are in dangerous territory. Because one object may change the state in a way that another object may not expect. For example, let's say you have two view controllers at the same time using the same service. You pass the same instance to both view controllers. Let's say you have an iPad with two screens and you're using the same service. One starts creation, the other one cancels it, and you're going to cancel the request for both view controllers.
Right.
So the way you design this service is not shareable, right? You're going to have one service per client, and that's it. You cannot share it. If you share it, undefined behavior.
Yeah.
So you're limiting the usage here.
Yes.
Every time you create a new view controller, you need to create a new service, and maybe that's okay, but you're limiting how you can use the service. Because things that are stateful, they are dangerous when they are shared.
Okay.
So back here to the service, if you return a cancelable, you don't force your service to be stateful. Now it can be stateless because it just creates a task, returns it, and it's up to the client to cancel the task and hold a reference to it as needed.
Right.
So you don't even need this shared base interface, for example. Now you have compile time guarantees that you won't have the issues with calling these two methods and then calling cancel and having undefined behavior at runtime.
Right.
Because you return an instance that holds the state for that specific request. So as you say, you can even call this a task, right? Something like that. So you return a task and then you can cancel it for a specific request.
Right.
Thus you can call this method multiple times and handle each request independently.
Right.
Following the interface segregation principle and the single responsibility principle and the open close principle.
Got it.
Let's look at the implementation. What happens if I call cancel? We cancel both. There you go.
Yeah.
There is the example Caio was saying before with the JSON mapping.
Of the results, yeah.
Right. So here we are, well, basically we're crashing. If this mapping cannot complete.
Yeah, this function is doing two things, right? It's parsing and performing the request
and
handling the result and converting the result and creating the view model response.
Yeah. It's responsible for doing everything between making the call from the from the UI, a user pressing the button to getting a response.
Yeah. Yeah.
So what is the problem with this? This code is not very composable. It's not very extendable. Any change,
right,
you need to come here and add a new if statement.
Right.
It's just hard to compose it with different behaviors. For example, if sometimes I'm going to talk to a service that returns XML. Well, you're going to have to pass a boolean here. Is XML, for example. And have another check.
Right, yeah.
If you don't follow the principles, you're going to find yourself in some tough spots and you don't have enough time to refactor your code, or you don't have tests to give you confidence to refactor your code. So what do? You keep adding more if statements, you keep adding more responsibilities to the type until it becomes unmanageable. You need to rewrite the whole class.
Right.
So you have an add or update view controller that talks to an add or update service.
Correct. When
does it add and when does it update?
So the very first time, if there's no results available, you'll add it. Once you have a result, if it detects it, there's a result available. I believe that's why it's an optional. If there's one available, then it calls the update.
So how do you get a result here? Who would set this result?
Whoever's making the call to this view controller.
Let's see. Dot result equals. Okay, you have a VC view controller builder.
Yes.
Right. You know at creation time if it's an add or if it's an update, right?
Yeah, yeah.
But how do you know in the view controller if you're going to add or if you're going to update?
See, I would check if there's a result. If there's a result, I'm assuming we call update. If there is no result, then we add.
Right. But where's the else? If result, you did this. Oh, create result.
Oh, there it goes. Yeah.
You also check if there's a result in the create one.
Yes. So see where I'm calling the create result, and I bet you, I mean, this was written a long time ago. I bet you I'm creating a result locally.
Right. Here. Oh, save button
yeah.
checked. There you go.
Oh, man. Yeah. Line 185.
Okay, here. If there is a result, we call update result. Else, we create a new result. There you go.
And notice how there are two types of results. The requirements for this, I made them up, or a session is kind of like a class. You know, you have you have your session at 3 p.m. For the gym. If there's no session, that means that the result you just went on your own. You know, you worked out at home and you want to add a result to whatever workout you did.
Right. This decision here is made not by the view controller if it's going to update or not. It's made by someone else. If someone sets a result, the view controller is going to behave in one way. If someone doesn't set a result, the view controller will behave in a different way.
Yeah, you're right.
So this logic could be moved to another layer.
Right.
Because one complaint we get from people that says, well, but if I'm going to follow the interface segregation principle, I'm going to end up with a bunch of protocols.
Yeah.
No, if you end up with a bunch of protocols, you need to ask yourself, is there something wrong with my design? Because maybe we can find a design where there will be only one protocol.
Right.
So if you have a result set, you should update. Yeah, so ideally we should pass a result here, right?
Yeah.
And then we don't need to check. The same for the create. But we have a lot of duplication here, right?
Right.
And they all call a method with the result, and the response does pretty much the same thing. Anything else that changes here? It just changes which method you call on the delegate, right?
Correct, yes.
Is it important to know if it was created or updated to the delegate?
I don't think so, no.
Yeah, because everything else is duplicated here.
Yeah.
So let's see if we can maybe create a different abstraction. What did I break? Oh, here. Update result is if let result equals result, update result.
And then here.
Create result. And let's set self result equals result. Same thing here. There's application here as well, right?
Yes. Actually, I can't remember as far as this code, but you see there's that method that on line 185 when I create a strength, I don't know what's changing. I guess it's just assigning the session to the result. That's about the only difference that I would see.
What about the result date? We don't have a result date here. Is that a mistake?
I believe, yeah, that sounds like a mistake to me.
So we could probably replace this and say result okay, less duplication. What is this is independent result here?
That's the thing that I was mentioning, that the user didn't go to a class. They didn't go to a 3 p.m. class, 4 p.m. class. They just went to they wanted to log a result that they did independently at home, at the park.
Because I also notice you have a boolean here. Is independent result. Is that even used? Oh, it is. But you define if something is independent or not, depending if there is a session or not, right?
Correct.
So is this even used somewhere else?
On the builder.
Oh, the builder sets it.
And they're both true. Because it's defaulted to false.
So this is independent result because it doesn't have a session.
Correct.
Right. So we have two ways of representing if something is independent, right?
Right.
Nothing stops someone to set a session here but forget to set this. Or set this and forget to set this.
Right.
And then your UI will show some buttons that they shouldn't.
Yes.
This should be maybe a computed var. This can even be private. And we remove these two checks here. If you don't give it a session, we're going to treat it as independent. But this looks like domain knowledge that should be encapsulated in some domain object.
Right.
We'll see this later. Do you have any compilation errors?
Yeah, I don't know why.
Oh, I think it's the name task we gave to the protocol. Let's say iTask. It's some kind of conflict with the names. Okay, it's building. Right.
Can I ask you guys something before you continue?
Yeah.
So I know this is a very good example because it has a lot of responsibilities. It has to determine whether it's independent or it's not, and it has two ways of determining if it's independent or not. It has to determine whether it hides or displays a certain components, certain views, and it also has to determine whether it calls the create or the update method. I found some responsibilities, but I'm sure there are plenty more that I don't see.
Yeah.
A Boolean already shows you this class does at least two things depending on some state, right?
That's it.
Every time you pass a Boolean to a function, you're saying sometimes it's going to do some things, sometimes it's going to do some other thing.
Right.
So the more Booleans you have, the more responsibilities you probably have. And how would you deal with that? Well, if you have tiny types, if you follow the solid principles, you're going to end up with composable types.
Yeah. And I think I went about doing this style was because the view looks exactly the same for add or update. So everything else must be reusable. There has to be a way to throw everything in on one file, right? Or one set of files.
Yeah, the view is reusable. You can reuse the view, you can reuse the storyboard.
Right.
Make sense?
Yeah.
All right. I think I'm changing the wrong class. This is a different one. This is a time result.
Right.
Let me undo this. We were in add or update result.
Result.
Yeah, there you go. So this is the one we want to change. Which means we have some more duplication in this other result time view controller. Because it looks so similar that I didn't notice.
The Xcode didn't know where to go either.
Okay, where were we? We were refactoring the save button tapped. Right.
Mm-hmm.
So you have the update one, and you have the create one. And we said, why is the view controller deciding this, if it's creating or not? Especially because it's deciding based on some given data to it. So you can move this logic maybe to the service. What if we had an interface that exposes one method instead of having an interface with two methods, create and update?
Mm-hmm.
Then now the view controller needs to know, am I creating or am I updating? Maybe this is irrelevant to the view controller. The view controller is only going to get data from the view, the user input, pass it to the service, and that's it.
Yes.
And that's all the controller does.
Yeah.
Because right now the controller is doing too many things. It's violating the single responsibility principle.
Right.
He deals with the views, he configures the views, he handles the user input, then he validates the data, and then he communicates to the server in very specific ways. If I'm creating, if I'm updating, he knows if it's a session or not, if it's independent, if it's not independent. Too many things in there. It's not easy to extend that view controller. So we said that we can break these into two protocols, but then people complain that, oh, now I have 300 protocols in my code base? No, we don't need that. What if we had let's say a result service, and it has one method, save result. Because save can be create or update. It's not up to the view controller to decide that.
Right.
I'm not going to change the view model here. We can deal with this later. Now the implementation side. We have one service implementation that does both adding and updating. What we could do is to create two services. We have the create result service that implements the protocol we just created.
Mm-hmm.
So it has only this method here. And the cancel will only cancel this one request, right?
Yes.
Now we can have another service. There is the update result service that also implements the same result service. but it does the update in this case. Makes sense up to now?
Yes.
So we had a protocol with 2 methods. We created a new one with 1 method. And now we have 2 implementations of the protocol. So we have a single responsibility principle. We have a service that does only one thing. And then we have 2 implementations of the service, and each does only one thing.
Right. And now our names are a lot smaller also. It's only doing one thing. We got rid of that or.
Mm-hmm. So result service, and then you have a create result service implementation and an update result service implementation.
Yes.
So that was a simple breakdown of responsibilities. We don't have more protocols. We have 1 protocol with less methods, and we have 2 implementations. So we have less lines of code,
right,
and a more extendable design now. So how could we use that? So ideally, I should be able to pass a service to this view controller,
right,
rather than this view controller creating its own service.
Right.
Because if I'm able to inject a service, I can inject different types of services. Sometimes I can inject the create service, the update service. Sometimes I can create, I don't know, a mock service.
Right. Yes.
Now this should be a result service.
Yeah. And creation is a responsibility as well, right? So this was one of the responsibilities of the view controller.
Yes, that's one of the things I never thought about. I never thought that was a considered responsibility point, right?
Right.
Every time you create something, that's a responsibility. Instantiation.
Yes.
It's a very strong coupling.
Right.
So here, let's make this a variable for now. So we can set from the outside. Let's make it optional for now. So how would you use this service? So now this is save, result.
Yes.
Oh, it's optional. And now we have the create result. That should be just save.
Save.
Just for now. Just to compile. One thing at a time. Okay, building. Perfect. Now, who calls create or update? Here. This method that decides if it's going to create or update. This logic should be moved. We can move it to the VC builder. Where is it? You have the independent result.
Right.
And you have the general.
The general view.
Okay.
That's it. So here, we need to move the logic for now. So let's see. If the view model, that's how you set the result here, has a result, we will set it here.
Correct. Yes.
Else, if you have a session from the view model, you will set it like this. Oh, so this is not optional. You always have a session in this case.
Yes.
Okay, so we can do it like this then. Else, we just set the view model session in this case. Look at that.
Yeah.
Now, does the view controller even need to know about the session? Where is this used?
Only there, but we don't need it anymore, right?
This has been moved.
Yes.
This logic has been moved.
Yeah.
This logic has been moved. And this logic has been moved.
Yes.
That's it. We don't need a session here anymore. But we still need the is independent.
Yes.
Because there is some UI that needs it, right?
Yeah, just for the UI now.
Okay. But we don't need a session, which is good. Now back to the factory here. We don't need to pass a session.
Yes.
So, okay, we moved the result creation here. Now we need to give it a service, right?
Correct.
So if you have a current result, it means you need a update result service. Otherwise, you have the create result service.
Yes.
So the view controller doesn't know about the concrete type anymore. It doesn't need to know about if I'm creating or if I'm updating. So this update method goes away. and we have only a save method. Let's refactor it. Rename. Save. Look how much duplication we removed.
Yes.
By following the principles. You don't end up with more protocols. We don't end up with more types. We end up with less types, less duplication, more composable types.
Yes.
All that logic deciding if I'm creating or not went away. The duplication went away.
A lot of the confusion went away. Right? Yeah.
That's very good news.
I think that's an important thing. We spent so much time trying to determine this or that, or,
I don't know if you've checked out the book that we provide in the course. In the third part of the book, we just have a list of metrics that can easily work as signals for identifying violations of the single responsibility principle, the ISP, or the least scope substitution principle.
I will have some time now, so I'll definitely check it out.
Yeah.
All right, we say some renaming here. We can call this what? Save result?
Yeah.
Or edit result? Is this what it does?
Yeah, it's editing. Yeah, result.
Yeah.
I like save. Both sound good though.
Let's go with save then.
It's a lot more understandable. Right?
Yeah.
All right, so we have two methods in the delegate, and you said that it doesn't matter, right? It could be just one result saved.
Yes, I believe it doesn't matter how many you have.
Let's do this and remove this, and let's see if we can get rid of it.
Yeah, this might open up another can of worms. Yes.
Here you just reload. But they should do the same thing,
Yeah.
right?
You're doing the updated. So yeah.
All right, so now we have a protocol with one less method as well. And now the last one. What is this protocol for?
Add or update view controller. Good question. I can't remember this one.
Is this even used? Oh, I removed this and it still compiled. So we don't need that.
Yes.
Yep. Can I rename this? Save result. That's it. We got rid of another method in a protocol. So this formatter and this validation logic could also go somewhere else.
Yeah, for sure. For sure.
So we already saved, 56 lines of code here. Just by improving the abstraction and following the single responsibility principle. And you can do more refactorings. You can do this on your own, like move this logic to some validator, something like that.
So I have another question as far as like the UI controller. So if you notice, this view controller handles a lot of the UI components, a lot of IB outlets. But how do you go about handling with different components for IB outlets? Did you just put it onto one view controller? Because at work, we do work a lot with view controllers that have so many views, different.
It's the scale here, where you want to be.
Yeah.
You want to be in the small scale that is composable, testable, maintainable, or you want to be in the rigid, immobile, fragile?
Correct.
Yes, you need to look for duplication. That's one sign.
Right. And how about the modification of a view? Let's say we have a programmatic view that I create programmatically, but I have to tailor it to my own needs, change the color here, change the text this. Let's say it's about 30 lines of code to modify to my likings. Is that to be done? Is that considered a responsibility to be done here?
Yeah, it's considered a responsibility, but doesn't mean you should not do it in the view controller, right? It is a responsibility, right? It's configuring. But maybe it's okay to do this in the view controller. But let's say you want to use this view controller, the same view controller, but have different configurations for the view. But it's the same logic, but sometimes I want the background to be green, sometimes I want it to be red.
Right.
Then you can move this logic somewhere else. Otherwise, you're going to have an if-else in your view controller by passing a boolean, if it should be green or red, and suddenly, sometimes it can be yellow, sometimes it can be orange, and suddenly you have like a huge switch case of configuration in your view controller. So maybe you move that to a view configurator, or you moved it to a storyboard.
Right. But at least it'll be separate, right? And then you know how we had that other builder. That's where we could set everything up.
It's a good place to inject stuff, yeah. Use different configurators. So that's it. So we had a protocol with two methods, which was a smell that it was violating the single responsibility principle and the interface segregation principle.
Right.
And then we broke down into two protocols at first. And we saw that that was not the solution. The solution was actually to have a service with one method and two implementations of that. So following the principles will not lead you to more abstraction, more protocols.
Mm-hmm.
We end up with a smaller protocol with implementations that are tailored to specific use cases. And when you create the view controller, you decide, depending on the data you have, if you want to update or create.
Right.
You move this responsibility to the composition layer. So let's say you have a new rule. You can only update your results if you are logged in. You can create when you're logged out, but you can only update when you're logged in.
Okay.
Let's say in the old implementation, you would have to add some rule here, like if logged in,
mm-hmm.
or if not logged in, return, right?
Right.
Or fail instantly.
Right.
So you would say something like guard logged in, or is logged in, else you would complete and return. Not logged in error.
Mm-hmm.
Well, not in the creation. Let's say you're going to do this only in the update. Here. So to add this new check, this new business rule, you had to change this type. This is an open-closed violation.
Right.
But you could add this behavior without modifying this type. You could create a class, let's say user authentication decorator. So this is the add or update user authentication decorator that implements the same interface. And you see why the violation is a problem. You have a create method and you have an update method.
Yes.
And you would instantiate this with another service, which is the decoratee. That's the decorator pattern.
Right.
Then you add the new behavior, checking is logged in.
Right.
Let's just say
it's a Boolean for now.
Yeah, let's say you're going to have another service that's going to decide if you're logged in or not.
Right. Yeah.
And then you would return not logged in error. Let's create here a simple struct just to compile. Okay, that's it. And if you're logged in, you forward the message to the decoratee. Then you update with the result and with the response. Mm-hmm. So look at that. By having an abstraction, even the one you had with two methods, we can extend the behavior without changing it. We can add this behavior here. The problem is we only want to do this in the update result.
Yeah.
But I am forced to implement these even though I don't want it. And I just want to forward the message. So this is a smell. This is called middleman. It doesn't do anything. It just creates one extra level of indirection unnecessarily. Mm-hmm. And that's a violation of the interface segregation principle. Mm-hmm. Imagine now if I had 5 methods. I'm going to have to type a lot of code just to add a tiny behavior here that I wanted. This validation. Let's say an error here.
I think there was an invalid. Yeah. Unauthorized. There you go.
Yeah, and another thing that this pattern allows you to do is to maintain the purity of your types in terms of crossing concerns. For example, a service, why would it know about logging, for example? You know, like having a logged in user or a logged out user.
Right.
This is part of the authentication, authorization layer of the system.
And it's a cross-cutting concern because this authentication may affect multiple features, multiple modules. Cross-cutting concerns like validating analytics authentication should be moved to another layer.
Right.
Otherwise, you couple all the features.
Mm-hmm.
So all the services should be free of the knowledge of even like the existence of a user, perhaps, or the existence of authorization levels.
And you can also create decorators to move threading to another layer, so your types don't need to know about dispatching.
Yes.
So how would this be with this new abstraction, the result service? Result service. And this is a result service user authentication decorator. And now we just need to implement
Save.
Save. Exactly what we want. We are decorating the save operation.
Yes.
Another problem where I need this cancel thing.
Yeah.
And then I need to pass it forward. That's why this cancel should not be in the protocol as well.
Yes.
So need to solve that. But this is already better. So let's say I want to decorate this in the builder. Here.
Mm-hmm.
Now let's say now we have a new rule. You can only create if you are logged in. Well, it's done. You just do this. The authentication is reusable for any result service.
Mm-hmm.
That's why you follow the solid principles. That's composability. So you have all this reusability, and replaceability, and composability at your fingertips as you need it.
Yes.
Because small interfaces can be decorated, they can be composed, they can be reused, they can be extended and tested in isolation.
Right.
Otherwise, you would end up with this logic everywhere.
Oh, yeah.
You would end up with this logic here, and then you would add this logic here, and then you'll be everywhere.
Just don't check out the rest of the code, because I'm serious. They have that or singleton, right? Singleton solves everything, or passing it as a variable. But then that's what I noticed. You know when you feel you've done something wrong, but you don't know why. It's passing it as a variable, a Boolean that says is the user logged in or not.
Yeah, because you don't want to be duplicating this in all your services, you will move it to another layer, like the request handler that is used by all the services. And you will move the logic probably in the perform get, let's say. And then you need to pass this logged in as a Boolean.
Yeah. Correct, yes.
And then you start adding Booleans everywhere because you don't have composability. Everything's concrete.
You don't have an option.
Then you need to pass the data all the time. All the clients need to know about internal implementation details.
Yep.
Mm-hmm.
Yeah, that's a simple example. Did it clarify some issues you had with understanding and applying these principles?
Yeah, most definitely. Obviously, I have to apply it more. I definitely go through the process of maybe continue finishing this class that we worked on.
Mm-hmm. I'm going to create a separate branch and you can have a look at it.
Okay, sounds good. Thank you. I started working on this project again, working smaller tasks again, mainly the homepage, applying everything I've learned from the courses, trying to apply even the module separation, right? I want to do that, just maybe add it on, maybe just create one view, but for both iOS and for the watch.
Yeah.
See how that goes, how much duplication I didn't have to write, right? I'm excited for that.
That's the power of modularity, and when you can reuse stuff, your life is gonna be easier, much easier, for sure.
Right. Yes.
And write tests.
Oh yeah, definitely. I feel it allows you to make more changes writing unit tests, but I like the part where it makes your code a lot more flexible.
Mm-hmm.
Right. When you write more tests, flexibility, you make change, and then you could rely on them. One fails, you stop there and you fix it, right? You don't continue and then I'll come back to this later, and you don't get these unexpected results.
Yeah, it's the quick feedback and constant feedback you get about the design, about the implementation, about the runtime behavior, about everything.
Yeah. Well, one thing I do have to get used to is having the patience for all of this. I think I mentioned it to you. I was known as the speedy developer that gets things done quick. The turnaround was impressive, but then time went by. So now the changes are just they're a lot better, a lot easier, quicker to make.
Yeah. So if you measure it in the long run, you will be faster as you get better at testing, following good design processes. Maybe you feel like you're going slower, but if you actually measure it in the long run, you're going to go faster.
Yeah.
Right.
That's going to allow you not to worry about your future. And as we said in the beginning of the session, maintain a very low cost for changes. So if you're a business, that's what you care about, right? Because if you have to rewrite stuff all the time, then that's not good. The profits or whatever are going to suffer there.
Yeah.
Because it's just too expensive to rewrite everything,
Yeah, tell me about it. Okay, yes. As far as the solid principles, that's all the questions I had. Cool. That's it, guys. I don't want to take the entire day. No, but you guys definitely were helpful. I learned a lot more like this, handling all the if and else and the whys, not just, not telling me this is when you do this, because then like you'll never find another scenario that's exactly the same. I read this on the book. I know how to apply it.
Yeah.
Right.
Yeah. Classic.
So, definitely. Yeah.
Yeah. And let us know in the course, like in the comment section, like if you have a question or anything.
Yes, for sure. Cool.
Absolutely.
All right,
cool.
Man. Thank you, Mike and Kyle.
Thank you. Thank you so much, Jose.
Happy New Year.
Happy New
You
Year.
too, guys.
Yeah.
New Year.
Bye.
Bye.